Hi again. In our last video, we saw that the amount of salt in water affects how the water freezes. We also saw that when salt water freezes, the salt is rejected or pushed out of the ice, creating tiny channels. And by the way, these channels are often used as microhabitats for ice algae, zooplankton, and even tiny fish. So I wanted to know, is there any difference between the frozen sea ice and the unfrozen water? And to find the answer to that question, we're going to make a saltwater solution, freeze it, and compare the densities of the sea ice and the water that didn't freeze. So to compare the densities, we're going to use a hydrometer. And a hydrometer is a special tool that measures the density of a liquid or solution. If the density of a liquid or solution is 1.0, that means the liquid has the same density as pure water. If the liquid or solution is more dense than pure water, we will have a density greater than 1.0. And if a liquid or solution is less dense than pure water, we'll have a density less than 1.0. So let's measure our tap water to see how close its density is to 1.0. So here's my tube. Let's go ahead and pour the tap water in there. I just poured it. Let's take my hydrometer and gently put it in there so it doesn't drop. Let it go. And it's facing me. You guys probably can't see that, but it is 1.000. It's maybe just a hair over that. So it's just a hair over 1.0. All right, now what we're going to do is we're going to make some saltwater solution that has approximately the same salinity as the water found here in Antarctica. So to do this, I'm going to measure 2 tablespoons of salt in 1,000 milliliters of water. Here's 1 tablespoon. And there's 2 tablespoons. Now I'm going to stir this solution until all of the salt water is dissolved. So let's see what the density of the salt water is. Pour it into our tube. Take another hydrometer. Put it in. Oh wow. Look at that, it keeps bouncing up. I'm going to try and settle it down here. And it is 1.025. So you can actually see that there's a significant difference there. Okay, so now what we're going to do is we're going to place our saltwater solution in the freezer and see what happens. So stay tuned. Okay, so we're back and we have our saltwater solution, and I'm going to separate the part that froze, which would be the sea ice, and the part that didn't freeze, which would be the unfrozen water. So let me try and do this carefully. Here's a big chunk of ice. Okay, so this is our sea ice here, and we're actually going to melt that. Here's our unfrozen salt water. All right, so while we're waiting for our sea ice to melt, let's find the density of our unfrozen water. do this without making a mess. Alright, and let's get the hydrometer out. Carefully put it in. Whoa. Alright, so this is the unfrozen salt water, and the density, let me turn it just a little bit, is about 1.031. Alright, so now let's test the melted sea ice. And it has had a chance to melt. So we're going to pour this into our tube carefully. Alright, so let's compare. Here's our hydrometer. Let's see what the density of the melted sea ice is. It's kind of bobbling up and down here a minute. Let me just steady it. And it is facing me. It is 1.018. 1.018. We can see that the density of the sea ice was less than the saltwater solution. This means there isn't as much salt or any other impurities in it. The unfrozen salt water was more dense than the saltwater solution. So let's review. How did it get that way? Remember, the salt from the sea ice was rejected or pushed out of the unfrozen water, making it even saltier and more dense. That's why the Southern Ocean has some of the saltiest waters in the world. And remember, saltier water is more dense and will sink to greater depths. Thanks for joining us.